Welcome to Module E, Lecture 6. In this lecture also we shall continue our discussion about disaggregate mode choice models. In lecture 5, we discussed about various limitations of analysis information related to measurement error, related to use of proxy variable, difference among individuals, day-to-day variation in the choice context, and some of these we explained with examples, and also we gave you an example to tell that how multiple such limitations can impact the choice decisions. With this background, today we shall discuss about probabilistic utility model. All these limitations led to a big question that if such limitations are there and if we cannot overcome this decision, but also we want to improve our prediction or model output to match closely with the real behavior, then what can be done? The answer is, then think of a different modeling approach which can accommodate all such limitations of analysts, but still can produce a reasonable or closer results to the real behavior. So, that led to the development of probabilistic utility model. In probabilistic utility model, we try to then in a way capture the difference between the utility value as estimated by the analysts using his or her utility equation, whatever is used, and the utility value used by the traveler, because in each cases multiple examples we gave earlier, in each case you have seen that there is an error term. If I would have considered that in my utility equation, then I would have probably able to predict the choice correctly. So, one is the actual utility which is perceived by the user or the traveler, and which is actually influencing or impacting his or her choice decision. The other is what is the utility that as a modeler I am taking in my model. So, because we know that whatever utility we considered earlier, many cases the modeler cannot really take the complete or the true utility. So, we now write the utility function as shown in equation 4. That means, the true utility is actually a portion of the utility which as a modeler we are considering. So, that we can say utility function specified by analysts, and this is obviously the deterministic component, because here we are taking attributes and coefficients, all are there, and all such attributes are measurable and we are including them in the model, and this portion we can calculate, right. And for each mode or each alternative we can get a value of this. So, this is called the deterministic component of the utility, and in each case there could be an error. So, the true utility includes this utilities function specified by the analyst, which is V, plus an error term E. Now, this error term is a random component, and because E is random, the utility, the true utility is also a random component or random variable. So, you have now utility function which is a random variable, which includes a deterministic component which the modeler can quantify and get a value, and there is an error term which is again a random error or random component. So, the whole utility now become a no more a deterministic part, but it becomes altogether a random variable. Now, if I connect this statement to various previous examples what I explained in the context of the limitations of analyst's information. So, please try to connect this lecture with the previous lecture and the examples which were given. For example, in example 3, we explained you how due to the omission of a variable, the modeled utility and true utility could be different. You remember that for drive alone and carpool, we showed you that in one case we considered the car ownership and in another case we did not consider the car ownership. That effect was not considered. So, what was actually specified without considering the car ownership, that I have stated here for drive alone, for carpool and for bus, what are the stated or specified utility by the modeler. And then as we said that choice also was influenced by the car ownership. So, the error terms in the drive alone utility, in the carpool utility, what was there, that is also shown here. Now, for bus there was no such error term, because bus utility does not impact on the car ownership. So, this error term for the bus was 0. So, what was considered by the modeler is indicated here in column 2, and the corresponding error terms are considered in column 3. So, because these error term components that was not considered by the modeler, so the actual true utility or whatever was the distribution or what was the choice of mode and what was predicted by the modeler using the specified utility equation, the outcomes did not match correctly. So, here this is the error term. So, I can consider in the context of example 3, my error terms are like this as shown in the last column. For drive alone 0.3 into a plus 1, for carpool 0.15 into a minus 1. Okay. So, these are the two error terms which are shown here with respect to this example, and this was in the context of omission of a relevant variable. Now, similarly, if I consider example 4, we said that not everybody considers that utility associated with travel time same. So, we said that there are two groups of individual, some consider a particular value, okay, and this was related to this was not related to person to person variation, but this was related to the second example 4. Let's omit this portion and let us say, okay, we consider now another example, that is example 4. Recollect or remember this example where we said that the utility, true utility and the modeled or specified utility could be different because of the measurement error. And we gave you an example that we consider travel time maybe from zone centroid to zone centroid, right. But when you are considering drive alone or carpool, the actual residential location within the zone may not be of equal distance from the zone centroid. So, to different individual or different group of individual who are residing in different band, okay, to them the travel time may be different. So, for drive alone, what was considered by the modeler, that is indicated here as specified utility, and the error term indicates what was the actual travel time and what was actually value taken as the value of travel time, and this error is due to measurements, but again this is an error. So, we have shown you here again in column 3 that what is the error which made the modeled output using specified utility and deterministic model. Okay. The outcome is different, make the outcome different from the actual observed distribution of mode. So, in the context of this measurement error and the example what we took, the error term for dry balloon and carpool are as shown in this table in column 3. For bus there was no error. Okay. Now, we also took another example which is example 5, and there we said that person to person there may be different weightage to the travel time. The travel time, the disutility due to travel time may not be same to every individual. So, there in that example we considered say two group of individual, you can consider them as two income group, right. So, two income groups, they do not value or they do not consider the disutility associated with travel time as same. One considered the value double than the other group. But what we did? We did the utility, we did consider the utility as shown here under specified utility. So, this utility considered the disutility associated with travel time same for every user group, okay, because we did not consider any user group separately. For everybody we just took one equation, one value, right. But we have seen in that example that the group 2 value or put much higher weightage, double weightage to the travel time. Okay. So, in that case, if we can say whatever we considered that was actually appropriate for group 1. So, the error was 0 for group 1 in the case of drive alone, carpool and bus. But because the travel time was, the disutility was associated with travel time was double for the group 2. So, for drive alone group 2, the error term is again minus TDA, because they were actually it was minus 2 TDA. So, we considered only minus TDA. So, minus TDA was the error. Again for carpool also minus TCP, and for bus minus TB. So, in this example the specified utility and actual utility, what was the error in the specified utility, that is shown here relating to example 5. So, now we actually again discussed these previous 3 examples to tell you every time what was actually specified by the modeler and what was actually the true utility. They were different because we did not know the true utility. We as a modeler only have knowledge about the specified utility. So, what were the error terms in the case of these 3 example problems? One case, in this case what I say person to person or different user groups have different value. In the previous one measurement error, and in the first case it was due to the omission of a relevant variable. Now, if the true utility function is known, that means if these error terms are also known, and exactly as I said in all the 3 examples, if we knew this component or if you would have considered them in the specified utility, then there was no need to use representation such as V plus E equal to U. That means, true utility is specified utility plus error term, because if in each case just imagine that we included probably also error term in our specified utility function. Then there was no need to use such kind of equation that the true utility is the specified utility plus an error term, right. But in reality the analyst never knows the true utility function. Maybe in these 3 examples we showed you, so now you know what is the actual error. Such kind of errors could be there in probably every utility function we specify in a real world scenario or in a practical scenario. So, there will always be an error term which will be present, and whatever we are considering or whatever we are specifying as the utility, the true utility is not going to be exactly same for all the alternatives what we are considering. So, the error term accounts for what? 3 things it actually accounts for. Number 1, variables known to analyst that influence travel behavior, but are not included in the data set. That means, as an analyst, maybe I know that this variable influence the choice decision and I should have actually considered it, but I did not consider it for some reason. Maybe one possible reason that data is not available and so I could not consider it, right. Like for example, the proxy variable or omission of relevant variable, right. Karanaship I know should be considered, but I did not consider. That kind of problems may be there, because it is not only the model development, you want to calibrate the model. So, you want to know basically that what is the data that relevant data should be available. So, one part is variables known to analysts that influence the travel behavior, very well known, but are not included in the data set and in the model. That kind of problem, whatever error will be there. So, this error term accounts for such thing. Second, variables that analysts choose to omit from the model. That means, intentionally we choose the model since we cannot forecast them. For example, let me tell you that day to day variation I gave you. One day I am not feeling well, so maybe instead of traveling by bus, I traveled by car or by taxi if I do not have car, okay, or car is not available. So, that means I take a different mode, right. Or one day my family wants the car, so instead of traveling in car, I am traveling by bus. Now, such kind of variations, even if somebody gives you the data, can we forecast this, that what will happen after 2 years or after 1 year or after 5 years? Can we predict this? We cannot predict it. And if we cannot predict them correctly, cannot forecast them correctly, we do not want to include them, because development of the model is not for the only current scenario. We develop the model for the current scenario, so that the variables and the outcomes all are known and we can calibrate the model, but the model is developed for the future. So, we have to make sure that we can forecast those variables which are included in the model. So, we may choose to omit, because simply we cannot forecast. The third, variables that influence travel behavior, but are completely unknown to the analysts. Maybe there are something which some individual or for some alternatives are impacting the choice, but as an analyst I may not know that, because the behavior that behavior or that thing is not known. So, I may not even know that that is influencing, and I may not consider, because what we consider in the model, looking at the literature, looking at the discussion with the experts and the traveler, we try to select some variables, right. So, there is no guarantee that every variable which are actually impacting the choice are to be included. So, the So, the third component, as I said, that it is actually the deterministic component of the utility, right, which we take and which may not include all such components. So, the error term is the difference between the unknown utility used by individual and the utility estimated by analysts and is represented by a random variable. That is what we are saying, that is an error term which is a random variable. Now, as the true utility of the alternatives are also random variable, it is not possible to state with certainty which alternative has the maximum utility. When I am considering only the deterministic component of the utility, I can calculate the value, that for alternative 1 it is minus 10, alternative 2 minus 15, alternative 3 may be minus 20. So, I know clearly that which one is the maximum value of utility, and then I can say confidently that this is going to be the choice, because this is the alternative where for which the utility is maximum. So, according to the utility maximization principle, we can tell certainly that this is the mode that is to be chosen, because the utility is maximum here. In this case, we only know the deterministic component of the utility. The other true utility includes an error term, and the error term is a random variable. So, once the error term is random variable and the whole utility is random, based on only deterministic component, we cannot say that which one is going to be the maximum. It is not possible, because there is an error term which can take any value following the certain distribution. So, in general, what we can say at best, the probability that an alternative has the maximum utility. So, I know the deterministic component of the utility, and based on that I can say what is the probability that alternative 1, whatever utility we got, it is going to be based on that knowledge that it is going to be the maximum utility, that alternative, right. So, in general, what is found, that the probability that a particular alternative is chosen either increases or stays same when the deterministic component of its utility increases. That means, if the deterministic component of the utility increases, the probability of choosing that thing will either increase or may remain same, or either decrease, it may decrease or stay same when the deterministic component decreases, right. So, if the deterministic component increase, then the utility will increase, or the probability will increase of choosing that mode will increase, and if the utility decreases, then the deterministic the probability will decrease, because the deterministic component of the utility decreases. So, now the remaining time in this lecture, we shall try to explain you this statement with some example, that whatever statement we said, whether that is true, right. So, let us take an example to tell you the dependence of choice on deterministic component of utility. We have shown here two sets of equation. Equation 1, of course, one is further into 1a, 1b, 1c for 3 modes. Equation 2 is again for 3 modes or 3 alternatives 2a, 2b, 2c, and 3 is basically what the analyst consider, right. That is equation 3. So, let this equation 1 and 2 represent the true utility, and equation 3 represent the deterministic component of the utility, what we know and what we considered. And 1a, 1b, 1c, 2a, 2b, 2c are the true utility, right. Now, why we considered them? Because there is an additional term that was not considered in the utility equation specified by the modeler in the deterministic component, right. So, you can very well connect these to the previous example. You can say 1A, 1B, 1C, they are different in terms of considering the car ownership, which equation 3 does not include, and equation 2, 1 and 2 is different from 3 also in a term that the coefficient associated with travel time in equation 1 and equation 2 are different. Equation 2 case, it is basically double. So, the effect of difference in automobile ownership and the difference in the preference among population groups are accounted in this error term. Let the population be distributed as automobile ownership considerations, maybe 0 car ownership, 1 car ownership, 2 car ownership, and let us consider that the population is heterogeneous and there are 2 groups in terms of their weightage to the travel time, that is group 1 and group 2, what is the distribution. And if we consider that income is 6 lakhs Indian rupees per year and the travel time and travel costs are like this, then you can easily actually calculate that as per the deterministic utility equation, what the modeler considered, the utility values are minus 1.25, minus 1.13 and minus 1.23 for drive alone and carpool and bus respectively. So, as a modeler I said what? I said that the choice will be carpool, because carpool is maximizing the utility and in this case it is negative value. So, the minimum one is taken, right. But the true utility using equation set 1 and 2, you can calculate for each user group, group 1 and group 2, G1, G2 indicate group 1 and group 2, for 0 car, for 1 car and 2 car. Each case we have calculated the utility using this equation 1A, 1B, 1C for user group 1 and 2A, 2B, 2C for user group 2, using this travel time and travel cost values for 3 different alternatives. And we can see clearly the chosen modes are going to be for 0 car user group 1 bus, group 2 carpool, for 1 car ownership group 1 carpool, group 2 drive alone, and for 2 car ownership group 1 drive alone and group 2 also drive alone. So, what we will find? We know how much percentage of population belong to 0 car, 1 car, 2 car, and also based on group 1 and group 2. So, that distribution is known from this example. You know that say group 1 with 0 car 20%, group 1 with 1 car 25% of the overall population. So, we know it and we know how much percentage of population are there in under each group 1, group 2, and considering the 0 car, 1 car and 2 car ownership. So, and we know for each group or each segment what is going to be the choice. So, accordingly we know that what will be the actual real behavior. The real behavior, what we shall then expect to see? 20% people will use bus, 30% will use carpool and 40%, 45% will drive alone. Remember that this will be the actual distribution, because actual choice depends on car ownership and actual choice is different for group 1 and group 2 people in terms of their perceived weightage on the travel time. So, that is why we are getting this distribution in reality, but the modeler will predict what? Based on this utility value, modeler will predict that everybody is going to use carpool. Okay. So, this difference is due to the two reasons. One is that we have not considered in our model the car ownership, that is one part. The second is we did not consider heterogeneity in the group in terms of their perceived weightage on the travel time. So, we did not consider group 1, group 2 separately. So, while the modeler will predict that everybody will use carpool, actually observed thing would be that 20% will use bus, 30%, 5% will use carpool and 45% will use drive alone. So, that is what it is. Now, let us consider one more little bit addition. Addition is that let us consider we are now imposing a parking tax of 30 rupees for the drive alone, right. If deterministic component of the utility, what will happen? Then decrease from minus 1.25 to minus 1.48. Why? Because that cost will change in the equation. Look at this equation 3, 1a, 1b in all 1 and 2 also for the drive alone, these utilities are going to change, and for my equation 3 also as a modeler what we have specified, in that equation also the utilities are going to change. Okay. So, what I will find? I will find now that my as a modeler, what is my specified model, there also the utility of drive alone has decreased from minus 1.25 which was earlier value, and now because we have considered 30 rupees parking for drive alone. So, my disutility becomes 1.48 or utility becomes minus 1.48. Similarly, this will also have impact on the utility of drive alone for 0 car ownership, 1 car ownership, 2 car ownership people, and also for income group 1 and income group 2. So, those utilities also will change somewhere, and because the utilities will change, the utility maximization principle wise choice also in some cases will change. So, the change choices what actually would happen, that is shown here in this table. Again, I know the distribution of population across car ownership and across income group 1, group 1 and group 2 people. So, knowing that distribution and knowing the choice for each group, I can now find out that 15% people will use drive alone, 65% will use carpool and 20% will use bus. What was the result? True result? True result was earlier 20% bus, 35% carpool, 45% drive alone. So, 20, 35, 45. Now, what are the values? Now, 15, 65, 20. So, what has happened? The drive alone portion, percentage of people who are using drive alone, that has dropped. That has dropped from earlier it was 25, 20, now it has become 15. Why this has happened? Because I have increased the parking charges, I have imposed the parking charges of 30 rupees. Now, like that, I am showing you here one table where 0 parking charge, the first case, second case 15 rupees, third case 30 rupees. Now, in each case, what is the deterministic utility of drive alone as considered by the modeler? I do not know all these errors. I do not know that I should have considered the car ownership, I could have considered 2 groups of user, I do not know all this. So, in my consideration also the utility will change. First case it was minus 1.25, second case minus 1.36, third case minus 1.48. Similarly, the actual choice considering set of equation 1 and 2 and considering 2 in group, user group, group 1, group 2 and 3 car ownership level, percentage, their individual choice and overall distribution, the drive alone percentage will be how much? First case 45% in reality actual choice, second case only 40%, third case only 15%. So, what you are seeing here, as the disutility is decreasing for a mode, in this case it is drive alone. As the disutility, as the utility is decreasing, as the utility is decreasing, the percentage of people using that alternative drive alone is also decreasing. That is what the statement we made, that if the disutility of a mode increases, it decreases, then the probability of using that mode will also decrease. That is shown here. So, that all what we did, we tried to explain you this particular statement what we made earlier. We tried to explain you through some example. So, altogether what is happening? As you said that the probabilities is decreasing of choosing the drive alone, because you have, as you are increasing the parking charge or as you are increasing the utility of that particular alternative. So, utility decreasing, so probability is also decreasing. So, as parking charge increases, deterministic component of the utility decreases and percentage of population choosing drive alone also decreases. That justify this previous statement what we said about deterministic component and its change and the corresponding likely change in the probability of choosing the mode. So, what we discussed here in summary, we discussed the difference between the true utility and the utility specified by the analyst or the modeler. We gave you an example of specified utility and error terms, several examples we discussed. We explained you determinist component is what, that is what the analyst can measure, whereas the error term is unobserved and unmeasured. We cannot observe, we cannot measure also in reality. And we gave you an example of how the utility is dependence of choice on the deterministic component. With this, I close this lecture. Thank you so much.